This is our PR1 project proposal made by Charlize, Ruben, Lucas Shibuya.
Hello, my name is Ruben Cortez, and this is element A, identification and justification of the problem. So the main problem we are faced is that many people who bring their metal water bottles to school, they tend to drop it during class, and it disrupts the learning environment for not only the teachers but the students. And what we're trying to change is that if they were to drop it, it wouldn't make that much noise and it wouldn't disrupt the environment around the person who has that water bottle. To add on to the previous slide, I'm going to show you three examples of how your water bottle can be damaged, not only during class but outside of class.
Go. Go. Oh no. Go.
So over time, if you keep on dropping your water bottle like this, the damage is going to get exponential. The water bottle is going to end up losing its purpose if the vacuum seal in between the vacuum seal and the water bottle, if it is broken, the water bottle no longer serves a purpose. And as you can see to the right, a survey we conducted with around 200 responses, uh, you can see that a gradual amount of people do bring their metal water bottle to school. So this problem not only affects, let's say, two or three people, it affects way more than that. And this survey isn't just our school; it can go around to other schools like Wilson and Poly and all those other schools.
Hello, this is Elemental B, documentation and analysis of prior solutions attempts. As you can see, these are some of the pattern images that we use. One of them is like a clip, which can hold different kinds of drinks and cups. Another one is a beanbag, and one example of it, it's holding like a nail polish, how you can have in different angles too. And another one we have is the jar, which is made out of glass and has a protective sleeve, preventing it from it breaking. Here's like some questions that I tried answering. So for the first one, I said that they had the attempt to try and solve of protecting the bottle, like some of the products that we found, like had an idea like either to balance it or at least have somewhat of a protection with it, especially to stop making dents. For the second question, how we show the possible research that other people made, well, by looking at a little bit articles, patents, and existing products. Patents and existing products were the most main ones that we found that people attempted to solve the bottles from not denting. And for the third one, we had um, people to help our little problem, like our school, Sato, and other high schools like Poly and Wilson that helped us out. We also had our teacher to help us out a little bit of solving our problem. Here's where I explain how we use Google Patterns or like a main search, which we found many different helpful ideas or ideas that we might implement or change it a bit, because our goal is to just cancel out noise and damage. So these patterns that we use and we found by Google Patterns helped us a lot to implement. Some have good policies, some are bad, but they still help us out of figuring out our main problem.
Hi, I'm Lucas, and this is element C, the presentation and justification of our solution. Through the system of finding a solution, we went through many different requirements, looking through our different patents and looking through what was going to help our product. And the way that we decided these was going through each of the different patents that we found and looking at what they added or took away from the product that we're trying to protect, which is the water bottle. As you can see here, we try to ask ourselves a lot of different questions whilst coming up with the parameters. For example, how much time do we have? How much money are we working with? How complex is our problem? Because the people who worked on these kind of problems before us had to ask themselves the same question. We try to base our requirements on our research, both in general and focusing on the patent research. We wanted to find requirements based off of the solutions people have already made. The way we measured our success in our product and testing them through simulations, we would like, for example, to put a metal water bottle on the ground and accidentally knock them over and see how dangerous and noisy they are, as shown in the previous slides. Or if the product is meant to keep it in place, then put it on a table and shake the table so that we know how stable it is. As you see here, this is our decision matrix. We look over many different examples of people trying to fix this solution in the past and try to find what each of them have in common. The different specifications that each of them had helped us find our own that would help with our solution. Each of them at the end got a grand total adding up on a score of 1 to 5, looking at each of these different specifications and eventually getting total scores so that we knew which of these was the best fit for what we were going for.